This is Møller Nielsen from Geeks, and I'm going to teach you what the difference is between a DevOps developer and a regular developer. You might have heard the term DevOps before, but maybe you don't know what the difference is between the regular developer and the DevOps developer and which skills you actually need to obtain to take that role. Then this video is something for you. Now, as a complement to this video, there will be related articles and resources in the description below. Also, please feel free to visit our webpage at geeks.com. Take the time to like, subscribe, and hit that notification bell so you know when we have more stuff coming up. Now, without any further ado, let's get started. So this drawing shows the difference between the developers and the operations. This was especially like this in the old days. Then we had a special division that put software into production, and then you had another division which developed the software. In the beginning of the software development phase, then you would have some kind of planning where you would plan what kind of requirements there were to the application. It could also sometimes it was with the developer, sometimes it was the business people with a project manager, and then maybe some help with some architect that then could create this master plan for how to develop software and how they actually should be and which requirements the business had. Then we came to the fun part, the coding phase, where the developer could actually program something and just make it work on programmer's own machine. Then everything was fine. And then at some point, of course, the developer then could press some kind of button and use some tools like Maven, Gradle. It could also be NPM. It could also be SBT if you are a Scala programmer. Then you would build all of this code, which means usually compiling, running some tests, running some code quality on it, and then in the end, wrap all of this up into one artifact, and that could be like a jar file. It could also be a minimized version of your JavaScript. It could be, in old days, it could be a WAR file. It could also be an EAR file. WAR files, EAR files, and jar files, they are actually just zip files. It's actually just zip compiled code, and we deal with that. So that was the role of the developer in the old days. We had this structure. We plan something. We code something, we build something, of course we also test something, and then in the end, we're happy with what the test shows us. Then we get this artifact right here. The artifact would then be sent to operations. Sometimes it will be sent through a common registry, a repository somehow. Then the artifact will lie there, and the operations will get a task in the mailbox or in whatever system they used, and then they said, please put this into production next Tuesday, of course. And then the operations guy next Tuesday, he or she would wait until Tuesday, and then when it became Tuesday, then the operations person would then start this process right here, where we want to release something, we want to deploy something, we want to handle the configuration and management, and we also want to monitor the application. So then the application would then be go to the release cycle and then be deployed on some kind of some server that could be on a Kubernetes cluster. It could also be Docker Swarm. Of course, in the old days it would just be plain old servers. That's how it was done in the good old days. And then after that, then the artifact would of course undergo some monitoring. Then it actually would become an application, a running application instead of an artifact, and it would be a running application based on that artifact that would then be monitored. The monitoring part, of course, would also be very important. That the monitoring part includes log collections, which could be done something like Splunk or Datadog or another product where logs are being picked up. And of course, it will also be to pick up metrics like CPU consumption and also memory consumption, and also responses. So maybe you would measure how long it will actually take to generate some kind of response on a REST endpoint, for instance. So that is this is the division when you have a developer division and an operations division. This is not that normal any longer. Some places you still have a developer division and you have operations divisions, but experiences has shown that it's very important to break down this barrier because it's much more efficient if the developer also knows something about the operations, and if the operations also know actually how to develop. So a lot of places then this role actually is invented, which is called DevOps, and I'll just show you like this. So DevOps is a developer or more developer. It could be the whole team actually that knows both how to develop some software and how to create the application, but they also know how to place it into production. That could be, usually there is a very well-written description and process of how to do that, because of course it's if you're running Scrum, then you might have sprints of 2 weeks, and then actually be every second week that someone has to put the into production. And if you have a very good CI pipeline, which has been set up, maybe it has been set up half a year ago, and it has been of high quality, then it would just be run, so you do not have to think about placing the code on development and test environments. This is just done automatically. Then of course it can be a little bit difficult for the developer to remember and to see how the software actually goes from being just code and actually going into being an artifact, and then going through the release process and how to monitor it also. So that is why documentation is very important for DevOps, especially if it's a role that maybe the team takes turn having this role. Sometimes a dedicated person, or maybe more than one dedicated person, have this role, and then those people they both have the role of being a developer, so they create an application, but they also can place the application into different environments. It's not just production; it can also be other environments. It can also be setting up the continuous integration server, so you know when something is wrong. There's a lot of tools right here, and that is why the DevOps role can be a bit demanding sometimes. So as you can see here in the planning phase, we're dealing with LibreOffice and some UML and some diagrams. When we are coding, then we are dealing with source control management system and SCM system like Git. It could also be Mercurial, but it's less popular right now. So Git is usually the default choice. Then you need to know about an IDE, an integrated development environment. You need to have some kind of editor where you actually edit your code, and you need to master that, of course. That can be IntelliJ, VS Code, or of course also Eclipse or another editor of your choice. Then when you are dealing with code, that's usually, if you're running Agile, then you also have JIRAs, where you have your accept criteria, and these JIRAs or another system that can contain user stories and tasks. Then you would have something like Confluence, where you can describe your code, and you could describe whatever is needed for the code to come up and run. You can also place this in a readme.markdown file. But again, all of this is technologies. It's things you need to know. Then when you want to build an artifact, then you need to know about Maven. You need to know about npm. You need to know about Gradle if Gradle is used. Of course, you also need to know about Docker if you are creating a Docker image, because it is very normal nowadays that the end result is not a file like a jar file like it was in old days. Now the end result, the artifact, is actually a Docker image that can then be spun up wherever it should be. You need to know about testing. You need to know about how to test your code. You need to know about the difference between unit test, integration test, and end-to-end test also. Yeah, so there's a lot of technology. Then on top of that, then if you want to release the code also, then you need to know that there's something called, there's a CI server that can start the build automatically every time something happens in the Git repository. So you need to know about Jenkins, maybe some Bamboo, CodeShip, or something else, or another third-party CI server. The CI server is actually quite simple. Usually it just starts something. What is difficult and where the work lies is usually to create the the Docker file in the build process. You need to know about the clouds also, because you need to know about how to deploy something into the clouds. And I would definitely recommend you to look into Kubernetes if you don't know about that. And also Docker Swarm is also quite good. You also need to how to deal with configuration management, because maybe you need to know about some Ansible scripts or Chef scripts or Helm 3 that will actually make sure that the application is deployed correctly and only the correct communication is exposed to the outside world. You need to know about how to get those credentials inside the CI server, which is also usually which can be quite difficult also. And you need to know about where do you want to keep these credentials. Should they be stored in vault, like HashiCorp Vault, for instance, or in a cloud vault, Azure Vault, for instance. And you also need to know about monitoring. You need to know about Splunk or Datadog or Grafana or whatever is used at and popular, and what has been chosen by in the company where you work. So there's a lot of technology. So it is quite demanding to be a DevOps, but it's also a lot of fun. I would say so. It's a lot of fun, and you get an overview of the whole process. And if something fails in production, then instead of the operations just throw you an error in some kind of error handling system, then you could actually go and look at these errors, and you can actually also fix them, because you are both the developer and you are also operations, and it gives a much stronger setup, and you can fix. There will be much less downtime when you have to run with DevOps instead of developers and operations. It's much more flexible, it's much more efficient, and I would say it's much. Again, this is my opinion. It's much cheaper than running different departments. So, and it's also more a lot of fun. In old days, there was also a lot of there could be some personal problems between developers and operations, where operations will then if something goes wrong, then the operations will complain that the developers, they never know how to create the artifacts, so it suits it suits the infrastructure down here, something like that. And also the other way around, the developers might accuse the operations also always for being too slow, and when they want to put something new into production, then it has to wait until next Tuesday, where they actually have time to do it. So it led to some frustration, also some frictions between the divisions. So that is also why it's a good idea to break down these barriers right here, and then have something called DevOps. And sometimes it also goes under a full stack developer, if you can develop both the code and if you can also place it into production. So let us look at a flow, because usually we have a developer, which is this happy face right here. And the developer creates some code, and this code is then pushed. It's committed and then pushed to the Git repository. The Git repository, it is possible to set up something called webhooks, which then calls the CI server. The CI server, it could be Jenkins, it could be Bamboo. It's actually just a machine that does something. So it does not need to be an advanced machine. It just needs to be a machine that can accept the webhook, and then can start a job. And the job that needs to start is actually to build final Docker image that need to be placed on a development environment or a test environment automatically. And this is called CI, continuous integration. We want to see all the time that our application is actually works, and that it could actually go into production if we want to. That is the job of the CI server, to continuously build, to compile and build the code and run tests also, so we can see that the code quality is okay, that there are not any more bugs than there were before, and not any more code smells, and that we do not use some insecure dependencies. Then we have something called the OWASP dependency check, which is also run through the build phase. And all of this should be part of the Docker file, because then it's quite simple. They can be run on any CI server. That means that if we choose to exchange the CI server from Jenkins to Bamboo or something else, then it's quite easy because we have a Docker file that builds everything by itself. That's also why I write local job, because when you develop this Docker file, you need to make it work on your own machine first, so you can actually you can spin up this Docker file, and then it should create final Docker image. Then it should be able to place that on the Docker registry. Let me just create this is the image right here. So Docker image. So this is a final image. It will be built and created on a CI server with the Docker file, and then it will be pushed to the Docker registry. And all of this setup, this is when you are the DevOps, then this is your job. You need to make sure you need to set up the webhooks on your Git repository, which could be a Bitbucket, for instance. Then you need to set up the webhooks, so the webhooks actually call the correct CI server job. And you need to make sure that whatever is going to run and to be spun up, then there's actually some there's a server or an agent that can actually handle. That is your job as a DevOps. Then the image then will be pushed to some kind of Docker registry. In the Docker registry, there are many choices right there. I will show you some of them in just a while. Then after pushing the image to the Docker to the registry right here, then the CI server needs to send configure the Kubernetes cluster, which we have right here. That can be through Helm 3 scripts, for instance. It could also be through Terraform, or it could be Ansible or Chef or some other configuration management tool. But the most important thing is that you need to have your configuration as code. You need to have infrastructure and as code, and then of course also your configuration as code. And if you're dealing with Kubernetes, then I would recommend that you use Helm 3. It's quite good. Then inside these Helm 3 scripts, it would actually say that it should spin up the Docker image inside an application pod, which we have right there, and it should add some environment variables. Maybe it should also make sure that there are some ingress rules that would route the traffic correctly to this application pod right here. So that is actually it. So it sounds. It doesn't sound of much, but there's a lot of things that can go wrong right here. The CI server needs to have credentials for the Docker registry. It needs to have credentials for the Git repository, because after it gets a message with the webhook, then the first thing it actually does is it clones a project, checks out the whole project where the changes were located, and then it finds then it is configured to build the Docker image with the Docker file right here, and then it also needs credentials for the Kubernetes cluster. So there's a lot of things that need to be okay, and the Kubernetes cluster needs to have something called a pull secret for the Docker registry also. So the Docker registry is the Kubernetes cluster is allowed to pull from the Docker registry. So there's a lot of setup right here. There's how should this CI server run? Should it be through webhooks, or should it be something that is scheduled where it checks for changes every 5 minutes? I would definitely recommend that you use webhooks always. So there's a lot in the setup that can go wrong. There can also sometimes there might lack resources on the CI server. The agent that runs it might not have the resources to run this huge build, and the build was working fine on the developer's own machine, because then he had a really powerful laptop. That is very common nowadays, that you have these powerful right there. Another thing that can go wrong is if you are, of course, we need some code quality on our application, and there I would recommend you to use SonarQube. SonarQube can both collect code coverage percentage. It can collect. It can actually do static code analysis, which means that it can look into the code and it can see that there are code smells or bugs, and also security vulnerabilities. It can actually also check that, and it can also tell you how you should have coded, how your code should have looked like if you wanted to avoid avoid these problems. And another thing the SonarCube also can give you is something called a quality gate, where you say that if the code quality is fall below 70%, then you do not want to place this, then you don't want to continue, then the build actually breaks, and the end user will actually get an angry email that says that your build actually failed. So that is one possibility. Also, if one of the unit tests failed, then the developer will also get a message with that. If suddenly the Docker file cannot be run anymore and the Docker image cannot be created, if the developer made some changes in there, then of course the CI server would also send an email and complaint to the developer. Whatever makes the CI server job fail will lead to an email to the developer. OWASP dependency check, that is a tool that can actually go through all of the dependencies. For instance, for Java, then you in your Maven or in your Gradle file, you will have a lot of dependencies. If there are vulnerabilities like the latest Log4j vulnerability that you might have heard about, then the OWASP dependency check will fail and will tell you that this is a problem. So there are a lot of things to think about, but let us just go through them, see if we thought about all of those. Which Git repository should be used? Right? So a lot of times there is actually a company standard, so you don't have to think about which product that needs to be used. But sometimes there's actually not. Maybe everything is up to your team. Maybe it's a startup company. Then you need to think about which Git repos should things be placed in, which Docker registry should be used, which CI server should be used, and especially this one right here with the CI server. That is something that the DevOps would probably have a lot of opinions to. So one DevOps person might favor Jenkins, and another one might favor Bamboo. So this can lead to a lot of discussions right here. Then you need to know which Kubernetes cluster that you need to use. You need to know what should the demands for code quality be. Should we break the whole build when the code quality is not fulfilled? Should we have a quality gate, or should it just be a kind of an? Of course, we could still be notified, but the application will still build, even though that the code quality is not as good as we would hope for. Then there's the security. Where should we store all of our credentials in this setup right here? Should they be stored in a vault? Then, or where should the secrets for the Kubernetes cluster be placed? That could also be something that you have to worry about and to think about. We have the whole configuration of the application. We have the scaling in a Kubernetes cluster. When you are defining a deployment, then you can say or how many percentage of CPU should be used before another pod should be spun up. So let's say that you have maximum of 80% CPU. Then when the CPU is used more than 80% of the cluster node, then another pod will spin up automatically. This is one of the cool things about Kubernetes. It will actually scale up and down. Elasticity is one of the buzzwords. It will do that automatically. Then we have the HTTP communication to the outside world. That is also something we need to configure. That is configured with something called ingress rules. If you're dealing with Kubernetes cluster, you need to say that when you reach this endpoint from the outside, then it should reach this application right here. If it is another subdomain that is being called from outside, then maybe it's another application or a third application that need to be reached. All of these rules are set up in something called ingress in Kubernetes cluster. You need to renew and maintain the domain certificates. If you use Let's Encrypt, then of course that will do it for you, but you have to set up the Let's Encrypt Nginx ingress controller, and you have to configure that so it can use Let's Encrypt. But yeah, so there's a lot of things to think about. And that is why sometimes some people actually find it a bit overwhelming to be a DevOps, because all of these weird things that you usually would not think about when you're a developer, you would just make it work on your own machine, and then you would actually be happy, right? And what that is also the fun part. That is actually what why developers actually become developers. That is because they want to see something work, and they can see that work on their own machine. They might not care about the infrastructure. They might not care about the continuous integration. They might not care about code quality. A DevOps have to care about all of these things. And I think actually all developers need to know a little bit about DevOps, even though they don't want to take that role, and even though they don't want to be a DevOps. And I think that's part of development. You have to know how your code actually ends up into production, because that is where we create the value as a developer. Code quality, how many bugs is accepted? Is it just that there can not come any new bugs? Is that the criteria? How many code smells? Which code coverage percentage is okay? Do we care about code coverage percentage at all? Because the problem with code coverage percentage is that developers might be lured into actually creating tests for just getters and setters, or things that does not make sense, just to raise the code coverage percentage so the team is happy. And of course that is not the whole point with code coverage. You should use exclusions. Because all of the files where a test does not make sense, and there will be a lot of files and a lot of code where a test does not make sense, then just exclude it from the calculation. That is a good solution for it, instead of creating dummy tests that doesn't do anything. So then you have to think about how many and what type of test should we have. JUnit, you should usually have a lot of those, because those can test small pieces of your code, but you need to create those tests correctly. You need to create them so they do not break if one of the conditions break. You need to make them very flexible. You need to make them as flexible as possible, these JUnit tests. But of course, they should still give value, and they should still test whatever you want to test. So try to create these as flexible as possible, so they are easy maintainable. Because that is one problem that you usually run into. That is, you have some developers that are thinking a lot about tests and are really into code quality. Then they will create a lot of unit tests, but they might actually create them so specific that, let's say that the sales tax is suddenly changed for one country, then all of your unit test breaks, because they expect that when you use your sales tax calculator, then of course then they expect some kind of result. Write them very flexible, and think about if you can actually create tests that actually gets the sense, that kind of gets the purpose of can find the purpose of your methods, but it doesn't have to check the exact value. Then those tests will actually be better, because then they're easy maintainable. Unit tests should also be very fun. Not fun. Yeah, it should also be fun, but it should also be fast to run. So if you are thinking about integrating to other systems and you want to create some unit tests that does that, then tag them. In Java, you can create a tag. JUnit, you can actually create a tag on top of your tests, then tag them with integration, so they are not run by default when building the system and building the application. Then they will only run if you want to run them locally. Cucumber, business-driven development, is also quite good. Then you can actually add accept criteria from your user stories and from your tasks and subtasks. You can actually add those to Cucumber, and then you can actually see those go green. Usually your business would actually like you for doing this, because then they can actually see that, or your product owner will actually like you, because then he or she can actually see that what asked for is actually right there inside the test, and the test is green. So of course the end-to-end test, you should have some of those, but not too many, because these are heavy tests and it takes time, because you have to spin up usually the back end, you have to spin up the front end. You also have to spin up a database. Sometimes you can use a H2 in-memory database instead, which is a good solution, I think. And of course, you also have to have all of the other third-party dependencies either mocked or either available to run Selenium tests. You could also run your end-to-end test on a target environment, so you know you always have a special environment for running this test right here. OWASP dependency check, I would definitely recommend that you run that. You can get a Maven dependency to run it. There's also a runner for, you can just run in a shell, so you can run it for JavaScript projects as well. And then a quality gate. Decide whether or not the build should actually break when the quality gate is not, the threshold is overseeded. The number is higher than the threshold. So that is DevOps. You need to know about this whole flow right here. So you're a developer. So you need to know about the business needs, and you need to create business value, and you also know how to actually deploy the application to all of this infrastructure right here. So it takes a toll, and sometimes sometimes this role goes takes turn, and sometimes it is a dedicated role. Let us look a bit about this. Let us look at the technology. Right, because the CI server, which server could we choose there? We could choose Jenkins. Jenkins is a very good choice. You can do whatever you want to do with Jenkins. It's very flexible, but you also have to set up a lot of things, and you have to think about a lot of things yourself. That is the downside. But you can do whatever you want to do with that. And there's a lot of plugins. There's a plugin for almost any big application out there, which means that you can just install this plugin. Of course, that you have to upgrade these plugins all the time, because data are made to these plugins all the time. But you can just search for a plugin and then try Kubernetes. And we have all of the Kubernetes plugins right there. There's also plugins that can look through logs. It's still only the imagination that limits what you can plug in with Jenkins. Bamboo is a little bit more strict, but I really also like this one. Bamboo has with Bamboo you can define agents, and then you can say what the purpose of these agents are. This means that it feels a bit more like when you're creating a new plan, as it's called with Bamboo. Then it feels a bit more like you're going to the shop, and then you can actually pick stuff from the shelf. It feels more like that when you're dealing with Bamboo. When you're dealing with Jenkins, it feels like that you are almost like you're programming, because usually you would actually also have something called a Jenkins DSL, some groovy code that actually defines the job. So you have your you have your infrastructure code, and you also have your CI scripts as code. So Bamboo it's more user friendly, I would say, but it's also a bit more limiting if there's something you want to do which is not part of which has not been set up or made yet. Of course, then you cannot just do that with Bamboo. Nowadays, when we use Docker, and when we create a Docker image from a Docker file, then I would say I've actually grown a bit more fond of Bamboo these days. But Jenkins is also really, really good. I really like both. Of course, Jenkins is totally free, and Bamboo, it costs something, and it integrates easily because it's Atlassian who made it. It integrates easily with Jira and all Confluence, etc. So registry. If you want to get some kind of Docker registry, and let me just show you the drawing. This Docker registry right here. If you don't know which registry to choose, there are many options out there. Most of them start with a free 500 megabytes of storage, and then when you exceed that, then of course they want money for their time, money for their space, so to say. And so that is when the paid plans come in. But there's actually also free. You can also choose a free solution. I would not recommend the free solution. This is actually a Docker registry that runs inside a Docker container that we have right here, and this is okay if you don't want enterprise security or something like that. Then that is okay. If not, then there's all of these. JFrog has a free cloud solution right here, and when you say free cloud, it's up to, I think it's 500 megabytes. That's the usual limit. And then here you can actually get your own subdomain. So if you use JFrog's container registry, then you can get your own subdomain, and you can use it up to 500 megabytes free. And actually, I tried that, and it works great. You can also use, most of the clouds actually also have this functionality. This is DigitalOcean, which I also really like. This is one of the smaller clouds, or smaller. It is big, but it's not as big as AWS and Azure and Google Cloud. Here we can see these. This is the plan that we have right here. If you want to go up to 5 GB of storage and 5 repos, then it costs $5 per month. I like the prices here. I think DigitalOcean has some really, really transparent prices, and it's I've never been surprised negatively when I get the bill in the end of the month. I cannot say the same for the other clouds because they are very complex. Sometimes enabling stuff in the other clouds actually means that means a higher bill in the end. Especially sometimes then they change what actually how much things cost and what cost and what does not cost. And again, this So this was the DigitalOcean. Then we have some other. Then we have the other clouds, of course. We have Azure, and then we have Azure. They also have their own. We have the Kubernetes engine, and this can be run on any of the big clouds like Google Platform. Let me just show drawing right here. That is this place right here. This is actually where we run our application on the Kubernetes cluster, and that could actually be on the Google Cloud Platform. Of course, it could also be Azure. It could also be AWS, of course. Any of the big clouds will do that. It could also be on DigitalOcean. So those are the technologies, and there's a lot of things, of course, to dig into here and to get to become smarter and better at. I would say if you should just go one way, and if you should just recommend one setup, then I would say a Git repository here. You could use GitHub or Bitbucket. The CI server, that could be Bamboo, Jenkins, Docker registry. I don't think you should use the free one. I think you should use one of the cloud solutions. And again, in general, try not to set up things yourself locally or inside your Kubernetes cluster if you can avoid it. Use software as a service because it will save you a ton of time. There will be a lot more experts that have thought about security, for instance, which is probably not something that you will be an expert in. So you can use a lot of knowledge and you can get a lot of value out of using software as a service. So if you get your Kubernetes cluster just installed as a service somewhere on one of the clouds, then that would be great. If you just use the built-in CI server that is that is used for the cloud, then that's also fine. You can also get Jenkins or Bamboo as a service, which I would definitely recommend. Same with SonarQube. So if it was my setup, I would get as much software as a service as possible because it just saves a ton of time. And you don't have to maintain it whenever there comes upgrades. You have plenty to do with making sure that this pipeline actually works. And there will be plenty of, if you're a DevOps person, what also happens is actually then at some point a new project spawns. And of course, because you know about this whole setup, you know about this whole infrastructure, of course, then you would have to help this new project, or you would be recommended to help this project probably by the new. There might be a project manager on the new project, even though that they are running agile development and Scrum. Then sometimes there's still a project manager or someone responsible for the Scrum team that might want you to help the other teams. The good thing about being a DevOps, you will never. You will almost. Okay, I can say that you will be very. You will be wanted. You will be very wanted. You will be worth a lot for the company, because you can actually fill in. You can fill in both for putting stuff into production. You can also configure stuff. You can also code. So there will be a lot of job for you. The downside is that it can be quite stressful. Because, if something stops working in the pipeline, of course you have to fix that. Then everybody says, "Oh, the pipeline doesn't work right now. The Jenkins job stopped, or the Bamboo job stopped." What is wrong? Ask a DevOps guy, right? And on top of that, because you are a DevOps, then you also have to create value within the team, and you might have a user story that you're actually working on. Yeah. There are also in some companies they actually have dedicated DevOps across the teams. That means that you have a centralized DevOps function that then goes out and helps the teams when it is needed. Yeah. But that's actually it. It's a lot of fun, but it's also very demanding. I hope you liked this video. If you did, then please like, subscribe, and hit that notification bell, because we have a lot of cool stuff coming up. Bye.